Hello, I'm Aidan McGivern.
And I'm Clare Nasir.
And welcome to the Weather Studio. It's 1 o'clock, it's Tuesday. Every week at this time we come live with the latest on the UK weather, the weather around the world, exploring the whys and wheres and hows, and we will answer some of your questions. So send in your questions and we'll do our best to answer them today. Coming up
on our show today, well, we're talking all things rainbows. We all love a rainbow, don't we? Lots of question marks about how they're formed. But in fact, we've got some beautiful imagery of perhaps a rarer kind of rainbow. And the other question we all want to know, can you ever see the full circle? Is it just an arc? All those questions are going to be answered by our guest today, Jodie Ramsdale. That's in a little while. Also, 2018, will it go down in history as a record-breaking summer for us? We've got the latest stats and we compare and contrast with other years. It's looking very close. But first of all, have you ever flown across the deep south of the US, the southern states of America? Well, I have, and I have to say, Aidan, it's absolutely stunning. When I flew, the land was really red, it was very dusty, the sky was really clear, beautiful sunset, but I don't know how I would have felt if I'd looked out of my plane window and seen this.
Pretty scary.
Yeah.
Pretty scary. This was taken by Julie Wilhite, and she is flying into a dust storm. A dust storm, something called a haboob in Phoenix. Trying to land at Phoenix Airport, they made 2 aborted attempts to land before diverting to California. And take a look at this. What happens during a dust storm, during one of these haboobs, as they call them? The visibility reduces to 0. The winds whip up 50, 60 mile per hour winds. Let's take a closer look. Imagine flying into that. It would be pretty scary. 2 things you don't want when you're flying a plane is 0 visibility and the winds really, really strengthening. So, of course, they did divert the plane. But haboobs are a common occurrence this time of year in Phoenix, Arizona. Now, they happen when the winds pick up, associated with violent thunderstorms, and you see this huge wall of dust get whipped up, and you can see it from a distance approaching you, and it can be quite a scary thing. Interestingly, haboob isn't, it's not an American word, it's the word they use to describe these things in Arizona, but it's an Arabic word because scientists in the 1970s observed these storms in Arizona and said they were very similar to the kinds of storms that you'd get, say, in Sudan, where the word haboob originates.
Well, this plane is flying at what, I don't know, 3,000–4,000 feet maybe, and that wall of dust is towering over it. How big do these haboobs get?
Well, they can get up to 8,000 feet in the sky, so they are huge storms. And they reduce the visibility from a clear sunny day to almost 0. And like I say, they're associated with huge thunderstorms. And here's an example of a recent thunderstorm in Phoenix as well.
Yeah, backtrack to last Friday, and there were flood advisories out across Phoenix. This is Phoenix last Friday. In fact, it looks more like the state of Florida during this time of year. Monsoon season there, hurricane season in Florida. And look at that. It's absolutely, well, it's dramatic weather. In fact, it broke some local records, up to ½ an inch of rain in some places, which is perhaps not that unusual, but even so, for this part it was. Some incredibly strong winds. And 1,000 people lost power as well. So with these thunderstorms, you get lots of really violent downdrafts, squally winds. It looks very violent
indeed.
Amazing
imagery. I remember learning about Phoenix, GCSE geography, and how it was just a sunny city, right? And apparently it's one of, if not the sunniest major cities
on the
in
Met Office app today, it's saying 41 degrees and strong sunshine. So yes, you'd probably be right, but not in this case.
Most of the year you'd expect sunshine. But around this time of year, from mid-July until around mid-September, they get a weak monsoon-like change in their weather. Now, it's not an official monsoon because Phoenix is, of course, a desert climate. They get so little rainfall, so much sunshine. It's a desert. But across this part of Southwest America and across parts of Mexico as well, at this time of year, the land heats up. Meanwhile, high pressure moves northwards across the rest of North America. And what you tend to see is these moist winds drift in from the Bay of California, or the California Gulf in particular, and that adds the much needed moisture for these thunderstorms to develop. So it's around this time of year that you do tend to get an increase in huge thunderstorms across places like Arizona. So it's a similar mechanism,
setup, isn't it?
Yeah,
Yes.
yeah. So we see a monsoon in India where you get a reversal of wind direction, and you suddenly see these moist winds come in over a large landmass, and you get a huge amount of rainfall. Huge difference between a drier, less hot climate and then hot and humid and thunderstorms and rain and all that sort of thing. And so we see that signal at this time of year, albeit a weaker one compared to the Indian subcontinent. But we have got a video coming up soon on our YouTube Learn About Weather channel, all about monsoons. So it focuses on the Indian subcontinent, but it also looks at other monsoons around the world, West Africa, Australia, and so on. So if you're interested, head to our Learn About Weather channel, subscribe, and very soon we'll have that video all about monsoons.
And the person who actually wrote that video is with us now. Her name is Jodie Ramsdale. She's part of the Met Office College, teaching all about weather there as well. Please come in, Jodie, because we want to talk about rainbows now, don't we, Aidan? And this is an absolutely beautiful sight. I mean, this is the sort of thing I'd have as a poster on my daughter's wall in her bedroom. It's absolutely stunning, isn't it? And quite dramatic in its own way.
It is, yeah. Well, just looking at it, it's absolutely beautiful. But they actually form in the same way. So a red rainbow is also known as a monochrome rainbow. You can see it has a sort of a red hue to it. But it actually forms in the same way to our multicolour rainbows. The only difference being is the position of the sun. We need it very low and close to the horizon. So occurring at sunrise or sunset. So really it's just a rainbow occurring at sunrise or sunset.
Now, if you just step out of the way there, Claire, we'll see it was Russell Whitehead photography. Just make sure we've got
go like that. There we go.
That's it. That's very helpful. You can just stay there for a moment. Other images posted online, Sarah. This was also in the Coventry area. So these were spotted in Coventry at around sunset, like you say.
Yes.
Beautiful red rainbow. I think you two can probably appreciate it more than me because I'm colourblind, so these actually look fairly normal to me. But Sanjay here posted this red rainbow, and he says heavy rain at sunset. So,
yes,
yeah,
that is the key.
A clue there.
Yeah, so the reason where we actually see red sunrises and sunsets is all to do with the scattering of lights. Usually when the light comes in from the sun, we see it as the human eye as white light, but it's a whole array of vast continuum of colours all blended together. But when it actually encounters our atmosphere, the longer wavelengths are scattered by the particles and gases in the atmosphere. This is known as Rayleigh scattering, and it's more effective at the shorter wavelengths. So we have the red colours, which are longer wavelengths, and the shorter wavelengths are sort of the blue colours of the colour spectrum. So as the Rayleigh scattering is more effective with the shorter wavelengths, that scatters out a lot of the blue colour. So which is why during the daytime our sky looks blue, but during the sunrise and sunsets that light is coming in from a more, has a larger chunk of the atmosphere to actually travel through. So that blue is kind of scattered out of the way, and all that is left is the longer red wavelengths, which is why we see these red sunrises and sunsets.
So red at sunrise, red at sunset, and if you happen to have a rainbow at the same time,
that's right, yep.
Rainbow.
All we need is the presence of rain, giving it away. So how a rainbow actually forms, we have so the light coming in from the sun, as it encounters a raindrop, it goes from from the air, so a substance that has fairly low density, to water, which is more of a higher density medium. So it actually undertakes a process called refraction. So this slows down that light as it actually goes from the air into the raindrop. So that refraction splits out that light into the different vast array of colours, and each wavelength is scattered or is actually bent, actually bent in a slightly different way. That's right. Yes.
I remember that at GCSE physics. Is the angle of incidence equal to? I mean, there used to be a song connected with it.
Yeah. So obviously
we sort of understand the basics, but there's so much more to it, isn't there?
Yes. So I suppose in terms of it scattering out the light, it needs to be of a greater angle to actually get that scattering. But obviously showing here, we can see that depending on where you are, so when you see a rainbow, take note of the position of the sun, because with its being higher in the sky, the actual the arc that you see is actually lower. So on the image there on the right.
Yeah.
So the sun's always behind you. When
Yes.
you see a rainbow, the sun's
Yes,
always behind
yes.
you. The rain's in front of you.
Yes.
So the light from the sun is coming in,
Yeah.
and then it's hitting those raindrops, it's refracting. And this here, this is the anti-solar point.
That's right. So that is basically the with the sun behind you, the rain in front of you is the shadow of your head is basically the anti-solar points.
Right.
And obviously that will change depending on the height of the sun.
So in the same way that we've all got our own shadow, we've all got our own
We
position
do,
of our
yeah.
head on the
Yes.
ground, we've all got our own rainbow, haven't we?
That's
Because
right. You know, I
the
love that
anti-solar
fact.
point
Yes.
will be unique to everyone. So although we might see the same rainbow, or at least that's what we think we see, it will be slightly different
That's
position.
right, because the angle that light hits you, because we can't obviously occupy the same physical space. We might be standing next to each other looking at the same rainbow, but because we are at a slightly, apart from each other, that light will hit us at a slightly different angle. So each rainbow is unique to the observer, which I just think is a fascinating
I saw
fact.
on, I think it was Instagram or something the other day, and I think it's one of our colleagues, Charlie, posted an image of a rainbow, and it was moving, because obviously it does
Yes.
move relative to the storm or the shower clouds.
Yes, yes.
And you don't really tend to see that, do you? Because you just have a split second, oh, there's a rainbow, beautiful. But if you actually do time lapse, you can see these things moving across the horizon, which is
Fantastic.
so dramatic.
Also,
Yes.
if you take this to its extreme
Yes.
point, then the sun behind you, the anti-solar point in front of
Yes.
you, that's normally on the horizon or below the
Yes,
horizon. That's why
yeah.
we see
Yes.
a rainbow as an arc. However, if things are slightly different, if you are a bit higher, I guess that anti-solar point is higher
That's
as
right,
well.
yeah. So if you are high enough, then you should be able to see the full circle of the rainbow, as we can just see here from this shot from this aircraft. It's just that usually the horizon gets in the way, so we only see this arc. But here, you're high enough that you can see the full circle of the rainbow itself.
This is a philosophical question that I've had conversations with people here at the Met Office. Is every rainbow a full circle when rainbows only actually exist in your own eyes anyway? So
Maybe that's a question to ponder, isn't it?
it's like that one, if a tree falls in a forest, no one's around to hear it.
That's right.
Does
Yes.
it still make a
yes.
sound? So it's something to think about.
Yep.
Now, John Keats accused Newton of destroying the poetry of rainbows
Yes.
by reducing it to its prismatic colours. But I
Oh,
think
right.
that you've helped with your science restore some of that
Yes.
poetry
Hopefully,
of the
hopefully.
rainbows. So yes, as ever, you've been an excellent guest, full of all sorts of insights on rainbows this time.
Okay.
Thank you very much.
Thank
Jodie.
you very much.
Jodie.
Bye.
In fact, we've had our fair share of beautiful sunsets this summer because the air has been so dusty, hasn't it? The air, particularly through the beginning of the summer, was so dry. There was smog, there were air pollution issues, but with that we saw some beautiful reddy orange sunsets. And in fact, 2018 could go down perhaps as a record-breaking summer, or could it,
Well,
Aidan?
funnily enough, someone's just asked, Ad Toons has asked,
Yeah.
is 30-degree weather in the UK over for the year? Because, of course, the weather patterns
Good point.
have changed.
Yeah.
It's not as hot. The
No.
heat wave is over. We're into this more changeable regime. But it's worth remembering that we do get 30 degrees, although we're not expecting it in the next week or
Yeah.
so. We do get 30 degrees in September.
Yes, you do.
We have had 30 degrees on the 1st of August a few years ago. So it's far too early to rule it out for the rest of the year. But it is a bit cooler at the moment. The weather patterns have changed. Does that mean this won't be a record-breaking summer? Because if you remember, 1976, of course, the heat continued well into August. I've been having a look at some of the numbers with help from my friend Dr. Mark McCarthy, a previous guest on the Weather Studio.
So for the rest of August, if it was going to be average,
Yep, so this is just assuming rainfall, sunshine, temperatures, all average for the rest of the month.
he's saying 14th driest,
For
isn't
the
he?
summer,
Yeah,
summer
Dr. McCarthy,
2018.
14th driest.
Now this is interesting
Yeah.
because the first half of summer was the driest first half of
Yes.
summer for comparable records, since comparable records began in the 60s. So we've had actually some more rainfall in the last few weeks. That's helped to top up those levels. So actually it's 14th driest if we get average rain.
Right, what's next then? Right, so if the rest of August is average, it'll be the 11th sunniest, so not in the top 10.
No, but if we get more sunshine, it will be higher, of course. But this could be the record breaker, could be, because it depends on if the rest of August is average or warmer than average. We're saying it's very likely to be one of the warmest on record, but it's going to be a very close call, because if you take a look at the top 3 warmest summers, 1976 actually the third, and this is taking into account the nighttime and daytime temperatures. So these are the numbers averaged over the summer, day and night. 1976, the third warmest, 2003, and then 2006. But look, there's 1/100th of a degree between the first place and the third place. And at the moment, we are running very close to these numbers.
So, 2006, I don't really remember it as being a record-breaking summer in any shape or form. And that's because it started off quite cool, didn't it? It was July where we saw those very, very high temperatures. And that's why I think it's all to play for still.
Yeah, it's still
even
very
though
close.
we're almost mid-August
I'll
now.
show you this graph, which Mark McCarthy produced for me. And it shows how close we are with those 3 summers. So this takes into the running mean temperature from the beginning of summer through to the end. So at the beginning, or quite a divergent field of temperatures there for the different years. And we've got 1976 in blue, started off quite cool, before increasing through the summer. And then we've got 2003 here. This is this year. We started off with a head start there.
So we're yellow, and we dipped a little bit and then peaked up again, didn't we?
So you can see how they diverge, and then they come together. And take a look at this. They're all very similar by this point in summer. And this takes the 3 hottest summers through to the end, and it takes us assuming average summer warmth for 2018 through to the end. So you can see, well, it's too close to call, basically. If we are slightly warmer, for the rest of August, we could be the warmest summer on record. But if we are slightly cooler, it could only be the 4th warmest summer on record, because we'll just,
And it's within a degree, not even that. It's tiny,
within
tiny.
hundreds
Yes,
of
it's
degrees.
crazy, isn't it?
Yeah.
Yes. Considering it's 40 years of weather, and that's how close we've got to the warmest. It's crazy, really. So is it going to be? Are we going to see more of those high temperatures across the UK, not just in the southeast, but elsewhere as well? Because it's all about the country rather than just one region, isn't it? We want to see warmth everywhere.
Well, the weather patterns have changed. Here's the Jetstream, this fast-flowing conveyor of air high in the sky, and that has returned to our shores. It's taken a long sabbatical. Now it's back, and it is directing areas of low pressure our way. Now, whenever we're on the north side of the Jetstream, we tend to have cooler temperatures. When we're on the south side, we get warmer temperatures. And you can see how it just wiggles up and down over the next few days across the UK, sending areas of low pressure, areas of cloud and rain, but also making those temperatures oscillate up and down day to day. So let's put on the temperatures, and you can see how it's always fairly cool across northern parts of Britain, but into the weekend it is looking likely that we'll start to direct warmer, more humid air towards southern parts of the UK. So still, all to play for in terms of whether this summer will be the warmest on record.
And it goes up, doesn't it? And on
it
Sunday, it really starts to
yeah.
ridge again, which is the pattern we've seen over the last few months. So, what sort of numbers are we talking about on Saturday, Sunday then, Aidan?
I think we're looking at certainly the mid-20s across southeastern parts of the UK, possibly warmer, depending on how much sunshine we get. And of course, with this humid airflow, you do tend to get a lot of cloud as well. So it's still too early to put detail on it, but it does look likely that this northwest-southeast split that we've seen in the last week, it will continue in the next week. And so that shows a significant temperature contrast up and down the country.
And if you're heading to Spain, where I've just been, whoa, it's going to be another hot one, isn't it?
It will be.
I saw temperatures of 37 last week, and that was along the coast, and they've really been suffering here. And with the jet stream pushing northwards, it does drag up a lot more warmer air across the whole of this part of Europe. So all in all, we're stuck in another pattern, it looks like. But obviously on all our social media channels and on our website, we update you 4 times a day. And with that, there are other brilliant broadcasts that we do, including the 10-day trend.
10-day trend. I'll be looking at that in some more detail, what's going to happen in the next week to 10 days. whether our weather patterns will change. Will we see a return of the heat wave? At the moment, it's looking unlikely. A couple of questions just before we finish. David Pott asked, why was it one of the coldest winters, and now we've got one of the hottest summers? Well, just to clarify,
Simply,
it wasn't one of the coldest winters, really. It wasn't far from average. We had cold spells through the winter, particularly at the end of winter and the beginning of spring. But yes, since the end of February, right the way through to around about a week ago, we've had similar weather patterns.
It's been a blocking weather pattern, and that's the problem, hasn't it?
Yeah.
We've seen one day after another where either the heat has built or it's got colder and colder during the winter months. And
Yeah.
there's been no mobility, there's been no modifying temperatures from the Atlantic bringing rain, and there's milder air during the winter and the milder air during the summer as well.
Yeah, so the Jetstream is a great moderating influence on our weather, and in the winter it tends to bring areas of low pressure, wind and rain, but mild air from the Atlantic, and in the summer, same weather systems will bring cooler temperatures, or cooler, I should say lower temperatures, cooler air. Now, the jet stream has been relatively weak since the end of winter, and we've had these high pressure areas, so we've had much more of continental feel to our weather. We're back to more of a jet stream influence now, of course. And yes, we'll be looking at all of that in the 10-day trend tomorrow, but you can keep up to date with all the latest through our Met Office social media channels, and we will be here 1 p.m. next Tuesday. Thank you for watching. Thank you for sending in your questions. I will see you again next week.
See you next week.